Okay, so we've got a question here where we need to find the extremal of this function here. F equals y prime squared plus 2y. Now we'll see here that the two functions involved are y prime, which is the derivative of y with respect to x, and 2 times y, which is y is a function of x. So y is our dependent variable and x will be our independent variable. But you see here there's no x included in here. Now the standard notation to start off finding our extremal is this one. Our integral is the integral from a to b integrated with regard to x, and a functional including x, y and y prime. So with this functional here, I'm going to input that and here with this function in here. So we've got I equals the integral from a to b y prime squared plus 2y, and that's all integrated with regards to x. So I'm not going to put the brackets in here because we can see that this is all enclosed inside the integral there. So this is our integrand. Okay, now here we've got f of x, y and y prime, but you'll notice here we've only got a y and a y prime. So basically we're in the form of f of y and y prime. That's what this function is in the form of. So there is a way we can do the integration on here using Euler's first integral. So basically what it says is our integral is f minus the partial of f with regards to y prime, and this is multiplied by y prime. So put the bracket around that and multiply that by y prime, and then that equals some arbitrary constant which we'll call c. Okay, so with this in mind, I'm going to need to find our partial of f with regards to y prime of our functional f here. So with regards to y prime, we've got 2y prime. So using the power rule, so the 2 comes forward and leaves us with 2y prime, and then the 2y has no y prime, so that's not going to give us anything except a 0. So our partial of f with regards to y prime, that equals 2y prime. Okay, so now let's write out this formula. So our f is y prime squared, so we've got y prime squared plus 2y, and then subtract partial of f with regards to y prime multiplied by y prime. So that's going to give us 2y prime times y prime, and then that equals c. Okay, so let's just clean this up. We've got 1y prime squared here and a minus 2y prime squared here, so it's going to leave us with a minus 1y prime squared. So now we're going to have 2y minus y prime squared, just put that up there, equals c. Okay, now our goal is to try and get y on its own, but we've got this y prime squared here spoiling the party a little bit. So let's isolate this, and maybe we can take the square root to get rid of that. So if we send this on this side, because we want to take the square root, we want to get rid of the minus, then bring the c over this side. So 2y, c on this side will become a minus c, and the minus y prime squared on that side will now become positive. So that's what we want. Okay, now that's good. We can take the square root of this now on both sides. So now that's going to leave us with square root of 2y minus c equals y prime. So y prime equals the square root of 2y minus c. Okay, right, going to clear some space on the board here, and I'm going to continue this at the top. Okay, let's take that to here. Okay, so my y prime equals square root of 2y minus c. I'm going to rewrite this y prime as dy dx. So dy dx, that's just the same as y prime. And then that equals square root of 2y minus c. Okay, now here all we need now is just a little bit of separation of variables. So get the y's on this side, x is on this side. So these two can interchange. So now I've got dy over square root of 2y minus c, and then that equals my dx. Okay, so now for separation of variables, all we do now is integrate both sides. So integrating both sides. Okay, so integral of 1 over 2y minus c, the square root of, that's just going to give us the square root on the top. So now I've got square root of 2y minus c. Then the integral of dx is just going to leave us with x. Okay, so now we've got a good chance now to get this 2y minus c out of the square root. We just squared both sides. So square that, 2y minus c equals x squared. Now bring the c over to the other side. 2y equals x squared plus c. So now my y, we got the y isolated. So y equals x squared plus c all over 2. And that is our solution.